In the last video we did some basic equations with radicals, and if you haven't looked at that first video on solving equations with radicals, you might want to do that, because we're going to start with some pretty complicated examples in this video. Alright, so let's start with this equation. Let's say we have the square root of x plus 6 minus the square root of x minus 2 equals 2. So you can see from step number 1 we're supposed to isolate the radical, and we're already in a little bit of a situation because we have two radicals and we can't isolate them both. We can really only isolate one. So let's go ahead and do that by moving this x plus 2 to the other side. I'm just doing that because it makes it positive. You could move the square root of x plus 6, but then you have a bunch of negatives floating around. So now we've got the square root of x plus 6 equals 2 plus the square root of x minus 2. And we're going to go ahead and do step number 2. We're going to take both sides to the power of the index. We have a square root, so we're going to take both sides to the second power. Here we go. This is where it's going to get fun. On the left-hand side, not such a big deal. It's just x plus 6. Square root and the square cancel each other out. On the right-hand side, we actually have a binomial, 2 plus the square root of x minus 2. You think of 2 as a term and the square root of x minus 2 as a term. And from the first video, hopefully you watched the first video, we saw an example that when you have a binomial squared, you don't want to make the classic mistake of just squaring everything inside the parenthesis. You actually have to write this binomial twice, and then you're going to do FOIL. And probably you haven't done FOIL with a square root of x minus 2 before, but hopefully I can help you with it. And we'll just take it one step at a time. So the left-hand side, we're going to leave that as x plus 6. And the right-hand side, we're going to FOIL this baby out here. So first thing we're going to do, and FOIL, I say FOIL because a lot of people use FOIL, but some of you may just think of it as distributing, which is fine. So we need to distribute the 2 into the parentheses over here into each of these terms, and then we're going to distribute the square root of x minus 2 as well. But let's just start with the 2. So 2 times 2, that's straightforward, that's 4, we got that. Then we have to take 2 times the square root of x minus 2. Don't overthink it, it's just 2 times the square root of x minus 2. That's all you can do. The 2's on the outside, the square root of x minus 2's on the inside. Okay, now we're going to go to this one, square root of x minus 2 times 2. Same thing, put the 2 in front, makes it look nice. Square root of x minus 2, 2 times the square root of x minus 2. Now the last term, we have to take the square root of x minus 2 times the square root of x minus 2. Thinking about that, let's revisit this rule we have, that the square root of anything squared, anything, is just that thing. What we're doing here is we're taking the square root of x minus 2 times the square root of x minus 2. And if you think about it, that is just the square root of x minus 2 squared. Therefore, the square and the square root cancel each other out, and it's just x minus 2. Anytime you have a square root of something times itself, you're just going to end up with what's inside it. And you've probably done this before when you're rationalizing the denominator. Let's just see. I know this is off track a little bit, but you might be able to relate it to something you know. Say you have that, and you want to rationalize the denominator. So you multiply both the top and bottom by the square root of 3. And on the top, you get 6 square roots of 3. And on the bottom, you're doing square root 3 times square root 3, which is 3. It's the same thing. You're doing square root x minus 2 times square root of x minus 2. That is just x minus 2. It's easier than it looks. You just got to remember that rule. I got to finish this one over here. We'd have to cancel this 3 with this 6, and our final answer would be 2 square root 3. Okay, let me erase that to give us a little more room. So that's the hardest part, I think, on the right-hand side, is foiling all this out. I know it looks like a mess. We're going to have to clean it up. Take a look at that foiling and make sure you understand that. That's a big step. On the left hand side, we're going to leave this as x plus 6 for another step, because we have to clean up what's going on the right hand side and gather some like terms. Okay, we've got a 4 and a minus 2, so we can put those together. That's just 2. And we have an x, a plus x. We can't combine that with the x's under the radical, because one's under the radical and one's not. One's an x and one's a square root of x. And then we actually have some more like terms. Oh, let's use this green. This right here, 2 square roots of x minus 2 plus 2 square roots of x minus 2 actually give you 4 square roots of x minus 2. It's just like if you had 2 square root y plus 2 square root y, that'd be 4 square root y. Well, instead of a y, we just have a binomial x minus 2 under there. Same idea. Alright, now let's see what we've got. We're going to have to, oops, I erased part of my directions. Index. Let's take this guy and write him over here so we have more room. I'm going to write it up here. So now we have x plus 6 equals 2 plus x plus 4 square root x minus 2. By squaring both sides, we got rid of one of the square roots. Our original problem had 2 square roots in it, and now we're down to 1 square root. But in order to finish this, we have to get rid of our second square root, which means we have to basically go back to step 1 again, isolate the radical, and go through the steps again. So now we want to isolate this square root of x minus 2. Okay, let's do that. Let's get rid of this x, so we'll minus x from both sides. Oh, look at that. My x's are going to cancel out. That's going to make life a little easier. That doesn't always happen. I got to get rid of this 2, so I'm minus 2 from both sides. On the left-hand side, I have a 4. And on the right-hand side, I've got 4 square root x minus 2. So I want to get rid of this 4. I'm trying to isolate the radical. This 4 times the radical, so to get rid of it, I have to divide by 4. And now I have 1 equals the square root of x minus 2. Okay, that was all step 1, isolating the radical. Now I need to square both sides again to get rid of the second radical. And I have 1 equals x minus 2. This is looking pretty good now. And I'm going to add 2 to both sides. So that gives me 3 equals x. Oh my goodness. Okay, so that's a long process there. When you have 2 radicals and they're added or subtracted from each other, you're going to have to end up squaring it twice. Especially if you have another term here, like a 2 here. If there was a 0 here instead of a 2, let me write that in pink. If there was a 0 here instead of a 2, when you added this square root of x minus 2 over, you wouldn't have had a binomial. And so when you squared both sides, you would have got rid of them. And that would have been great. But when you have this extra term of a 2 or some other constant, or even a variable that's not underneath the radical, it creates a binomial and you end up having to FOIL, and it's quite a process. So you really need to watch every detail in every step. I know it's frustrating when you make a small mistake up in your foiling or combining like terms and then it causes a problem at the end. Well, we really should check the answer here. Let's see if I have enough space to check this. Okay, let's see. So our original problem was the square root of x plus 6, and when x is 3, so that would be 3 plus 6 would be 9, minus the square root of x minus 2, so 3 minus 2 would be 1, equals 2. The square root of 9 is 3, the square root of 1 is 1, 3 minus 1 is 2. Excellent. So that worked. Alright, well I hope that helps. Helps you in solving these equations that have the 2 radicals in them. And what you might want to do is just try this problem again without looking at all the steps and see if you can reproduce it on your own.